Hi everyone, this is the problem I was attempting to do in seminar last night. Ran into trouble with screen sharing. So I wanted to review it with you briefly. Uh, Again, what it says is that this researcher wants to know if there is evidence using a level of significance of 0.05 that the medicine in question relieves pain in more than 331 seconds. And so we have to express that as mu greater than 331. And I said, that was the claim that was made. Since it does not contain the equal sign, that must be H sub A, the alternate hypothesis. The null hypothesis has to include all other possibilities, which is mu less than or equal to 331 seconds. And it also said that she sampled 53 patients, and in those 53, the average time for pain relief was 336 seconds, and it gave us the variance as 361, but we want the standard deviation, remember, which is 19. So they want the value of the test statistic. They also want to know if the test is one-tailed or two-tailed. We already know that. Going back, remember that we look at the alternate hypothesis. The inequality sign points to the right. Therefore, it's a one-tail right test. So we know the answer to this one is one-tailed right. The decision rule will be given to us. I did it manually in seminar, and also whether we reject the null or fail to reject the null. So what I wanted to do is to, and this is what I didn't do in seminar, I want to go to the workbook, and this is what you should be using. Notice down below we have 3 tabs, one for the mean hypothesis test, when you know the standard deviation of the population, one when you don't, and then for proportion. Well, we know the population standard deviation, it's a mean test, so what we're going to do is put in the null hypothesis mu here, which is 331, and the level of significance is 0.5. The sample size that she used was 53. The sample mean, 336. I'm just taking these from the problem. And the population standard deviation, remember, I had to take the square root of the variance. It was 19. So we click that, and you see the z test statistic here at 1.92. 1.92 is the test statistic. And so that's step 2 here. Enter the value of the z test statistic. Round your answer to 2 decimal places. And we know that by looking at the entry here for the z test statistic. Then what it wants to know is what the critical value is and whether we're going to reject or fail to reject the null hypothesis. So in the workbook, it gives you 3 situations. One when the alternate hypothesis takes the form mu not equal to, when it takes the form mu less than, and when it takes the form mu greater than. Well, in our case, our alternate hypothesis took the form of mu greater than 331. Greater than 331. So we want to look down here at this part of the workbook where it says mu greater than 331. It gives us our critical value, 1.65, and it says we're going to reject the null hypothesis. So if we go to the other part of the lab question, it says enter the decision rule. Well, the decision rule is reject HO if Z is greater than 1.645. That's the upper critical value. That's how we determine whether we're going to reject or not reject. Since our value from the test was 1.92, that is greater than the critical value 1.65, therefore we reject the null hypothesis. And remember, the reasoning behind that was this: if we plot the distribution, it's a right tail test. So this is the reject H sub O region. Actually, this is alpha equal 0.05. We have a critical value here, which is 1.6, right here, 1.65. And that is critical because it divides the do not reject region from the reject H sub O region. So we look at our test that we did with the 53 samples, and you see our Z value there came out to be 1.92, which is in here, clearly in the reject region. That's why they reached a decision, reject the null hypothesis. So hope that completes the problem that I didn't do. Look in announcements for another exam, another video, another example. And as always, if you have any questions, email me, afiducia@purdueglobal.edu.